Okay, let us begin with lecture number 30. In last lecture 29, we have proved different properties of a parallelogram. Now, maybe using some of those properties, we will prove midpoint theorem in this particular lecture. But before that, let us prove couple of theorems related to parallel lines. Okay, the first theorem goes like this. Let L1 and L2 be two parallel lines. L1 and L2 be two parallel lines. If A and B belong to L1, A1 is not B1. Let A1, A2 be perpendicular to L2. A1 and A2, A1 and B1 are the 2 points on line L1. If we draw perpendicular from A1 on to line number 2, let us call it A2 and B2, these are perpendiculars. Then A1 A2 is equal to B1 B2. A1 A2 is equal to B1 B2. So what is this theorem? This theorem is parallel lines are equidistant everywhere. Distance between two parallel lines is always equal. Doesn't matter where you select A1 and B1. Distance A1 B1, if you draw perpendicular, it will be always equal. Now, this is very simple because the moment you draw perpendiculars, then these two form pair of corresponding angles, and therefore we can say by corresponding angles property, A1 A2 is parallel to B1 B2. And it is already given that A1 B1 is parallel to A2 B2, and hence it is a parallelogram. A1 B1 B2 A2 is a parallelogram, and by previously proved theorem, in parallelogram both the pairs of opposite sides are equal, hence A1 A2 is equal to B1 B2. It is basically a rectangle also, parallelogram, and a special case is a rectangle. Therefore, this is very simple. Second theorem talks about three parallel lines. L1 is parallel to L2 and L1 is also parallel to L3. So there are 2-3 different cases, but let us consider one. L1 is parallel to L2 and L1 is parallel to L3. Then L2 is parallel to L3. L1 parallel L2 and L1 parallel L3. Then L2 parallel L3. That is what we are supposed to do. Now, majority of the students in the school, maybe the textbooks also, would like to prove this by drawing a transversal. Let line B, let line T be such that it intersects all three of them. But if we really get into the details of the proofs, then first thing that we need to prove that there exists a line which will intersect all three lines, and then we can use corresponding angle properties or alternate angle properties to prove that L2 is parallel to L3. Therefore, if without justification anyone draws transversal and says that let this transversal intersect all three of lines, then it is slightly wrong proof. It is not completely correct. Of course, if you get into the details of correctness of every proof. So we will do that theorem, common transversal theorem, that there exists a transversal which will intersect set of three parallel lines looking like that, and hence we can prove that way also. But the simple-minded, very easy proof goes like this. If L1 is parallel to L2 and L1 is parallel to L3, and if possible L2 is not parallel to L3, then they intersect. Now, if they intersect, they will intersect somewhere. Maybe the distance is long, but they will intersect. Let them intersect at point P. Then we have a contradiction. What is the contradiction? Contradiction to parallel postulate. Parallel postulate says if you have a line and a point outside line and a point outside the line, you can draw only one line which is parallel to L passing through P. That is the Euclid's parallel postulate. 2000 years before he has written this postulate. Nobody has is successful to deny that postulate till date still exists. It is very easy to understand. If you have a point outside line L, then you can draw only one unique line which is parallel to L passing through P. Now you can see the contradiction to parallel postulate, because P is not on L, but passing through P there are two lines parallel to L1. L2 and L3 both are parallel, both are distinct, they pass through P but parallel to L1. Contradiction to this, that cannot exist, and therefore whatever we have assumed L2 parallel L3 is not correct. Contradiction, therefore L2 parallel L3. So this is the most easy way of doing it, contradicting the parallel postulate. This is indirect method. Okay, now let us do the common transversal theorem. Common transversal theorem says that there are three lines, distinct lines, L1 parallel L2, L1 parallel L2, L1 parallel L3. Then there exists transversal, so the diagram is more or less same, L3, L2 and L. There are three lines, L1 parallel L2, L1 parallel L3. Now let us prove that there exists a transversal which intersects all three of them. Now suppose we choose a point A1 on L1 and A2 on L2. We need to prove that line A1, A2 intersects L3. Okay, so now what we can do is we can again contradict it to the L2. What we are supposed to prove is this line intersects, to prove that A1, A2 intersects L3. Now how do we go about it? If possible, it does not intersect. If possible, A1, A2 is parallel to L3. If possible, A1, A2 is parallel to L3 and L3 is parallel to L1. So if we take A1 on L1, A2 on L2 and draw A1, A2, then we are supposed to prove that A1, A2 intersects L3. A1, A2, suppose if possible, A1, A2 is parallel to L3, but L3 is given to be parallel to L1. But we have proved a theorem, if A1, A2 is parallel to L3, L3 is parallel to L1, then A1, A2 is parallel to L1. But A1, A2 is not parallel to L1, it is intersecting because they have a common point A1. So contradiction. So there is a contradiction here, and hence whatever we have assumed that A1, A2 does not intersect L3 is not correct, it will intersect. So this is common transversal theorem. After this, what we have is midpoint theorem. Now midpoint theorem goes like this: in any triangle, if M is a midpoint of AB and N is a midpoint of AC, then Mn is equal to half of BC and Mn is parallel to BC, right? So these are the two important things that midpoint theorem gives us. Basically, this is very important theorem in geometry, and the proof is extremely interesting, bit difficult, but I suggest you try your own, else you go through the video to understand the proof. Okay. Now this proof requires basically some construction which is outside the box, outside the triangle. You extend Mn up to K such that Mn is equal to Nk, join Ck. Okay. Now because n is a midpoint, n was a midpoint of AC and m was midpoint of AB, we have many midpoints there. So if you look at these two segments AC and MK, they bisect each other. Therefore the theorem that we have proved in last lecture, sixth theorem, that AC and MK bisect each other, implies AMCK is parallelogram. Right? Because these two diagonals bisect each other. Now because AMCK is a parallelogram, AM equals KC. This is first application of first theorem which we proved last time. But AM is already equal to BM, right? It is given that it is a midpoint. Therefore, this implies KC equals BM. KC is equal to BM. Now, because AMCK is a parallelogram, AM equals CK and AM parallel KC. That is also available by definition. Now AM and BM, it is one line, therefore AM and BM, they are same, therefore BM parallel KC. Right? So now this is the seventh theorem application. If one pair of opposite side is congruent and parallel, then it gives us BCKM is parallelogram. Right? So this is the result that we get. Now if BCKM is a parallelogram, then BC equals MK and BC parallel MK. But BC was 2mn, MK was 2 times mn. So BC equals 2mn and BC parallel mn. So these are 6 different steps by which you get the midpoint theorem. And do you see all 7 results of parallelogram properties? Few of them are very handy and useful in proving this particular result. Okay, doesn't matter if you have not solved this problem independently. Very few students make this construction independently. If they have not learned this theorem earlier, doing this construction is really a good job, out of box construction, and not everyone does it. So even if you have not got it, it is okay, but you must understand it and be able to reproduce whenever required. Now the next and the last theorem in this particular lecture is the converse of midpoint theorem, and it goes like this. If M is midpoint of AB and U is line parallel to BC passing through M, then U bisects AC. Okay, that is the converse of midpoint theorem, which we will do now. So we don't require this. What we are going to do now is, there is a line U which is passing through M and parallel to BC. We are supposed to prove that it bisects AC. That means it passes through midpoint of AC. If possible, it does not pass through midpoint. Right? So suppose this line U is passing through N and it is not midpoint, then I can always construct midpoint N dash. N dash is a midpoint of AC and N is not, if possible. But then I can always join M and N dash. Now N dash is the midpoint of AC. And M is the midpoint of AB. Therefore, by midpoint theorem, Mn dash is Mn dash is equal to half BC and parallel BC by previously proved theorem, by midpoint theorem. But it is given that Mn dash is parallel BC and it is given that Mn is also parallel BC. Again contradiction 2. There exists M which is not on BC and there are two parallel lines passing through M. Contradiction 2, parallel postulate. And hence it cannot happen. Therefore, line U will bisect AC at M. Now, in this particular proof, we have assumed that line U will intersect AC. Line U will intersect AC also need to be proved that it is not going to be parallel. It is easy but need to be proved. So, a rigorous treatment of this particular converse requires first line U intersect AC, second line U intersects AC between A and C, and third that wherever it intersects it is a midpoint. So the third part we have done here, and first two parts really require axiomatic treatment which we have not included in this particular course. But you need to know that if somebody asks you that what is the guarantee that that line U will intersect AC, then there is a method by which we can prove it. Okay, so this is what is the content of lecture number 30. Hope you have understood everything. There are 7 problems which you should solve. Try to solve, get your solutions, and if you are in doubt, be in touch with us. Okay, let us see you in lecture number 31. Thank you.